This is a question, the first question of 3 on inverse proportionality. The difference really between inverse proportionality and direct proportionality is that when we're looking at direct proportionality, let me just find a bit of paper actually to scribble on with this. Direct proportionality tells us that as one thing goes up, the other thing goes up. Okay, so it's a bit of a graph. It looks a bit like this. Okay, we start at 0, and something like this, of course, could have a different gradient. But actually, if, for example, we had cans of pop and price, okay, the more cans of pop you buy, the more expensive it's going to get. Okay, so you're always going to go up like this. Now, inverse proportionality is when we're looking at as one number rises, the other one goes down. Okay, so as one side increases, the other one decreases. So we might have something like a really popular one is how long it takes to complete a task. So hours spent on the task, and we could have number of workers on this side. Okay, and actually what's going to happen here is you're going to end up with something a little bit like this. Okay, because if you've got, for example, only one worker, this is just made up numbers here, but one worker, it's going to take a lot of hours to complete the job. If you've got 10 workers, it's going to take a lot less amount of hours to complete the job. Okay, and that's inverse proportionality, and it's going to look a bit like this. Don't get too worried about the graphs yet, we're not going to be doing those this lesson, but they are the main differences. Right then, two quantities x and y are such that y is inversely proportional to x. When x equals 20, y equals 6, and we've been given two questions about it here. Now this works in very much the same way as direct proportion, except whereas with direct proportion we had this, we had y equals kx as our starting equation there. In this situation we're actually going to have y equals k over x. Okay, that's to show that it's inversely proportional. So you've got two different equations to remember. One for inverse proportionality, one for direct proportionality. This is the one that we're going to be using today. And that just shows, and of course we're going to get this constant proportionality here that we're going to calculate, and it's going to be very similar to what we did last lesson, but we're just using a different formula. This equation up there, okay? So the first one, we've actually been given here some information. We're asked to find the value of y when x equals 40 and the value of x when y equals 2. The first thing we do, we need to get an equation, okay? And actually usually, often, not always, you will be prompted to do that in the first instance, okay? So it's maybe part A of your question. But we know it's going to look like this, and let's substitute in the values we've been given. So we've got 6 equals k over 20. So therefore, k is going to equal 120, okay, because I've multiplied up by the 20. So I'm going to now rewrite this equation, but using the k. Again, I'm not interested in the 6 and the 20. They were brilliant for this example, and they helped me find the k, but now they've kind of done their job. I just want to leave it in terms of x and y. But I've got the k, and that needs to go in there, because that's a constant of proportionality. That means that doesn't change, that is constant. Okay, it's a bit of a code word there for it, constant. So we're going to get our kind of 120 over x. Okay, so that's what it's going to look like, and that's what we're going to use for both of these parts of the question. Now we've done that, we've just got to work out the answers to these, okay? So for part A, find the value of y when x equals 40. That's a nice one, because actually we're already looking at y being the subject there. So for A, we're just going to plug this in. We're going to have y equals 120 over 40, which is 3. So that's the first one, easy, should be happy with that. And then for part B, a small matter of rearranging, but nothing you shouldn't be able to handle. We've been told that y is 2, and we've got 120 over x. Okay, we need to solve for x. Now just be careful, this actually came up a lot when we did trigonometry, and I know a few of you struggled with this, okay? The first thing I'm going to do is multiply by the x, okay, to get, when we're trying to solve things, if we can get rid of denominators, get rid of them, okay? And by multiplying by x, I get 2x equals 120, okay? Because this multiplied by x, the x's divide and give just 1, so we get 1 multiplied by 120. You can say they cancel out. Some people don't like that expression. I don't particularly like saying they cancel out, because it doesn't explain where they've gone, and it doesn't help you really. when you get onto more complicated rearranging and solving. Excuse me. So we get down to this here, 2x equals 120, and you should be quite happy with it from here. X equals 60, because we divide by the 2. Okay, that's the first one of those. Very similar to what we did yesterday. And again, and a very similar question to what we did yesterday here. These examples are quite nice because it should allow you to kind of compare and contrast with what we did yesterday. So in this table, f is inversely proportional to g. Complete the table. So straight away, we're going to use the equation, and this time not y and x, but f and g. So f equals k over g. And don't worry about that, okay? X and y are just, they're just variables. We just use them more than any others. Perfectly fine to use something different. So we are going to look, where have we got two values here that we can substitute in. This has only got a g value. Here we've only got a f value, but here we've got an f and a g. So we know that when f is 40, g is 9. So we can substitute those in to allow us to find out k. So when f is 40, k over 9. So then we're going to do 40 multiplied by 9 to find that k is 360. Okay, and so we're now just going to plug that back into this. Okay, it's going to go back into here, just with the k. And it's going to give us f equals 360 over g. And there we have our equation. That's the hard bit done. Okay, that's the hard bit done. We can now use that to fill in the blanks here. So, let's do maybe this one here first. So when g equals 45, we're going to get f equals 360 over 45, which I believe is 8. F equals 8, right. Yes, that's right. Yeah, because half of 90. Okay then, so, yeah, I'm doubting myself. No, that is right. So we're going to have 8 up here. And then that's the first one. And then this time we're going to have when f equals 10 for this one. Substitute that into this. We get 10 equals 360 over g. A bit like what we did on the last question, okay, just take it steady here. And then multiply up by the g, so we get 10g equals 360. And then we divide by the 10, so g equals 36. Okay, there we are. And as you can see, as one value is increasing, the other one is decreasing. So if we plotted those on the graph, we would get that kind of swoopy line. Right, last one here, a bit more involved this one, okay? So use your imagination a bit. A droplet of oil is squirted onto the surface of a container of water. The thickness, d, that's what the variable you've been told it's going to be is, of the patch is inversely proportional to the square of the radius, and we're calling the radius r. When the patch has radius 3 centimetres, its thickness is 60 microns. Okay, don't get too worried if you're not sure what a micron is. They use it to measure thickness, basically, on quite small things. So actually, if we picture this, we've got, you know, maybe a container of water here. A little sketch might help. We're going to put a droplet of oil on. And of course, that oil is going to be quite a concentrated blob of oil in the middle there, isn't it? But as it spreads out, it's going to get a bigger radius. Okay, so it's going to come out here. But it's still the same amount of oil, so it will get thinner. So it is inversely proportional. They have told us that. Well, that's why. Okay, as that kind of spreads out like that, that's what's going to happen. So we can, first of all, write up our equation. So we're going to have, are we given, the thickness d is inversely proportional to the square of the radius. So just watch out for this one, okay? The square of the radius. So we get d is inversely proportional to, we're going to have our k there, over the radius squared, okay? The square of the radius. And as we did last time, it's going to work in the same way here, okay? We're going to square this one. Sometimes it might be the root of the radius or the cube of the radius, okay? So now we've got that, we can plug in, we've been given one situation here, okay, when it's got radius 3, the thickness is 60 microns, so d is going to be 60 equals k over, and it's 3 centimetres, and now that is 3 squared though, don't forget the squared, which gives us 60, which goes to 60 equals k over 9, and then 60 multiplied by 9 is 540 equals k. So that's our k value. Let's put that back into this now. So we get d equals 540 over r squared. Okay, so that's our big equation there. That's the one that we're going to be using all the way through this question. And we've got 2 questions here, 2 parts to it. So I might just move this page up a little bit. Need a bit more space. So A, find the thickness of the patch when the radius is 6 centimetres. So we've got d equals 540 over 6 squared. That becomes d equals 540 over 36. Oops, missed out the line. Which equals, now bear with me, I feel like I should be able to do this in my head, however the pressure of recording it's getting to me, so let's 540 divided by 36, 15, I'm sure I would have done actually, is 15. Okay, so that's part A. So, and actually let's just check our units, microns. Okay, always go back to your question and just make sure you've answered it. And then we've got here the final patch ends up with a thickness of 1 micron, and we want to know what its radius is at this point. So we go back to this again, and we've got a 1 instead of d, because that's the thickness, equals 540 over r squared. I'm going to bring up the r squared, and I have actually multiplied it by the 1, but of course 1 multiplied by r squared is just r squared, okay, we don't need to write the 1 in, it's a bit redundant. And then the inverse of this is to say that r equals the square root of 540, which is, hold on to your hats, a long decimal, but we'll round it to, let's say we're going to round out to 2 decimal places because we're working in centimetres, 23.24 centimetres as the radius. So quite a big one actually, because don't forget radius is from the centre to the outside of your circle. It's this part here. So actually, yeah, it's coming up to nearly ½ a metre across. Given how it was when it started off, that's quite impressive. Right then, so there's your 3 questions. Make sure you've taken notes on those, please. Go back and pause and things like that if you need to get the notes down into your books. Really important, particularly these equations and, where are we? The main one. Okay, this one here for inverse proportionality. If anyone was curious about how to write that with the little symbol, I actually don't know what it's called, the little symbol, we'd have just y. Okay, y is inversely proportional, that's what that means, okay. The fact that it's underneath the k means it's an inverse proportionality, so it's very similar, okay, it's actually the same sign as what we use for direct proportionality. Okay then folks, good luck with those, get in touch if you need any help.